Welcome to the Affine Geometry Lab. This is my current workspace that I've created inside Gravity Sketch, which is this VR environment for 3D design and computer graphics, mostly used by artists and some industry designers. But I recognized some of the potential that it could have for mathematics education, and I decided to play around a little bit and show you the possibilities that are in its current implementation possible. So first thing you can see is your hands in this fully 3D rendered space. I can, for example, zoom in and out of the elements of the geometry. So this is a scene that I created myself. I introduced some pictures from my tablet and with some mathematics, and we have basically full freedom to include everything. So you can see the space stretches out to infinity. You can displace parallelly with a simple stroke of the hand. You can grab objects with simple sort of grabbing motion by clicking one of the buttons that feels like grabbing something. It's really intuitive. And then there's all kinds of options to manipulate the objects in space. So particularly interesting is the option to snap things to coordinates. So if we're talking about fine geometry, it might be useful, especially if we are visualizing axes like this, it might be useful to display the grid of coordinate points. So you can see how some coordinate points appear. And these might be quite interesting to, for example, given an analytical equation of a plane, find the correct orientation in coordinates. So now this is snapping to the coordinates in the so to the original inclination, and it's somehow preserving it because I have those in the settings. But if I just disable the grid, you would see how I can, if I disable it like this, I can move the plane freely. I can stretch it, I can shrink it, I can just reorient it in any way I like. So that's indeed just a way to play around and to set exercises, for example, given this equation, orient the plane in such a way that it will be sort of a graph of the equation and things like that. Then, of course, I have a little, so for example, you can always attach your pictures to your objects. So for example, now the name of the plane Q is attached to the Q itself, that's sort of hovering on top. And you can see how if I select all three, I can simply snap this button and they are now all attached together. Now I'll put it back. So you can, for example, bring, this is a blackboard. At the moment, we can only write in three dimensions. So it's not possible to actually write on top of this two-dimensional surface, but this should be fairly easy to implement. So at the moment, we cannot write. So best we can do is this 3D. We cannot write in 2D. So I have this weird 3D writing, but it should be fairly easy to implement to write on the blackboard. So let me just delete this. So for example, this one task, very simple, given an algebraic description of a line R and the plane N, find the intersection that we analytically found here to be X. So how to reproduce this geometrically, we could use the grid to be precise and actually find the exact point in some sense. With the correct implementation in the current version of the software, this is not really possible, but the software is in beta, so it is, I guess, reasonable to expect that some features are incomplete. So we can use the same color code. Something I really like is to sort of enhance the zoom so everything becomes larger. So you can really feel part of the world. Now you can see the lines, and with all the perspectives, I'm just parallelly transporting the entire space around me. And you can also even zooming more, and so you can really see the perspective of lines and how they intersect things. So with that particular, oh, this thing stayed in place because the ratio I think stays in place. But for now, let's try and do this particular task. So let's take the R line. So R line, this is our R line. So I have control of the line so to make it more visible. I can orient it in any way. So, if we say that this R line is sitting like this, and this end plane, or to make it bigger, it's sitting like this, or perhaps let's just bring it down and do it here. Then the blackboard is like, okay, so I need to find the intersection point. That's what we're calling X. So I get X down here. I can just place it carefully so that it matches that particular point. So now I am looking at this situation. I have this blackboard here, and I have the sort of geometric representation of that. And you can really sort of zoom in and perhaps take all three, reorient it so that you have a better picture. So you can really explore the geometry of it, and you can really get a feeling. So we can even zoom in all the way and live on top of the plane and be here and really be on the plane. So let me just get rid of this. And we are currently living on the plane, and we can see the line is stretching to infinity that way. And so we can simply look through the plane and see how it stretches down to infinity. So we can have this sort of spatial awareness of the whole phenomenon of intersection between a line and a plane. And of course, just by moving this around, I can have zoom out and have a sort of overall overview of the whole situation. So lots of things to implement potentially, lots of potential, especially linear algebra, affine geometry, of course, as I gave it a sort of name, Affine Geometry Lab. Lots of possibilities. In principle, the software is in development, and there might be other software like GeoGebra that is already being sort of translated and incorporated into VR environments. But this just represents really a big opportunity, I think, and one I am really excited to explore and to work on.